Hello, let us discuss some problems on effective mass. So the problem statement is, in a one-dimensional crystal, the energy of an electron varies with the wave vector as given by E of k is equal to 2k square plus k plus 1. So then, what is the expression for group velocity of the electron? So and options are given. So before solving the problem, let me explain what is effective mass and what is group velocity. So why they are important. So this concept is extremely important in understanding how electrons behave in a solid, inside solids, especially when analyzing band structures and charge transport. It is quite different from how electrons behave in free space. So let us discuss effective mass. So in free space, if an electron is moving with a velocity, so then there will be no change in the mass of the electron, so which is given by me. So I think you know the value, 9.1 into 10 power minus 31 kg. So there is nothing change, and also its velocity determined by using Newtonian mechanics, which is given by V is equal P by m. In quantum mechanics we can write h cut k by m. So where k is the wave vector. Right. However, when electron moves in a solid, it changes drastically. Its mass completely changes. Why? You know what is meant by a solid. So it consists of number of molecules arranged in a systematic way. So when an electron traveling inside a solid, the electron is not at all free anymore. It is influenced by periodic potential created by regular arrangement of atoms, ions in the crystal lattice. So this type of atoms will influence its mass and velocity. So this periodic potential significantly alters the motion of the electron. So this is where the concept of effective mass comes in. So the electron behaves as if it has a different mass. We call it is effective mass. So this different type of mass is called effective mass. So it is denoted by m star. So you can say E m star E. Okay. It reflects how electrons behave in external forces within the lattice environment. So different materials exhibit different types of masses for their charge carriers. For example, in silicon, this effective mass of electron is less than mass of electron in free space. Whereas in some fermion materials, effective mass is some fermionic solids. Effective mass is greater than me. So this effective mass is not at all a fixed quantity. It depends on the curvature of the energy band. So if you draw a curve for E versus K, K is taken on x-axis and energy is taken on y-axis. So it takes a form like this. Okay. So this curvature is important. Mathematically, the effective mass is defined using the second derivative of energy with respect to the wave vector. So mathematically we can represent this effective mass. So how? M star E is equal 1 by h cut square d square E by dk square. So we can also write m star is equal h cut square by d square E by dk square. Okay. So here So here Ek is energy of the electron as a function of wave vector. As a function of wave vector. H is the reduced Planck's constant. Okay. So here the important factor is curvature of this particular graph. So larger the curve, larger the curvature is equal to smaller the effective mass, smaller the m star e, and vice versa. Flatter band or flatter curvature tends to larger effective mass. Another important aspect is that electron's velocity. In a crystal it is not at all. So electron velocity in free space is p by m, but in crystal its value also changes because of the influence of molecules. So, and because of this effective mass, it possesses a group velocity, so which is given by v of k. Velocity is the function of wave vector 1 by h cut d epsilon or energy by dk. So this velocity directly comes from the slope of the energy versus wave vector. So both velocity and mass of the electron are determined by the shape of the energy band. So in conclusions, we can write effective mass m star is equal h square square by d square e by d k square, and next one velocity, it's not frequency v, it's velocity v, 1 by h cut d epsilon by dk, and it varies with energy band curvature. Okay. So with this conclusion, let's go to solve the problems. Okay. Now let us see the first problem. So in this problem, we need to find group velocity. So what is given here? It is direct problem. Energy in terms of wave vector is given. So 2k square plus k plus 1. So what is the expression for group velocity? V of k is equal 1 by h cut d epsilon by dk, right? So first of all we have to differentiate so this energy given expression. So d epsilon by dk square is equal d by dk of 2k square plus k plus 1, so which is nothing but 4k plus 1. So therefore v of k is equal 4k plus 1 by h cut. So this is the expression for group velocity. So now let us see the next problem. The problem is using the same energy dispersion. So what is the effective mass of the electron? So again we already discussed what is the expression for effective mass. m star is equal h square square by d square e by dk square. So in the previous problem we already found first derivative of du epsilon by dk, which is nothing but 4k plus 1. If we again go for a second derivation of this, so d square omega by epsilon by dk square is nothing but yield 4. So therefore m star is equal h square by 4. We substituted this value in the formula. So that's it. Now let us see the third question. This is a theoretical question. So what is that? Which of the following statement is true about the relation between energy band curvature and effective mass? So options is a flat energy band gives a smaller effective mass. A more curvature band indicates heavier effective mass. A large second derivative d square omega by d square leads to a small effective mass. And effective mass is not related to energy curvature in solids. So we already see expression for effective mass. What is that? M star E is equal h square by d square epsilon by dk square. Right? So there is a relation, inverse relation between m star by d square omega by dk square. So therefore we can say larger the value of, so if its values increases, larger the value of d square omega dk square yields a smaller value of m star. So option C is correct. So this is about effective mass. Thank you.